Ma'am, can you permit me to share my screen?
Yes, sir. You can directly share your screen, sir.
I am unable to share. I am getting message that permission must be granted to me in order to share my screen.
So just a minute, sir. हॅलो
Hello?
आनंद सर.
Yeah.
तर काय
Still I am
प्रॉब्लेम
unable to
येतोय?
share my screen.
हो का? डायरेक्टली होतं ना सर प्रेझेंट.
There is option here present now. If I click on it, what I make, the message I get is can't share your screen.
ओके.
Actually, you have hosted
हां.
meeting. So from your side, permission must be granted to me.
ओके ओके. सो लेट मी चेक सर. ओनली होस्ट सर.
Now, what I will do, I will log in through Chrome. Maybe problem is Firefox.
हाँ. यस सर. मे बी दैट मे बी वन ऑफ प्रॉब्लम. उन्होंने क्रोम थ्रू ज्वाइन करते हैं. हम्म. Now check sir whether you can present. See.
Yeah, now I am able to share my screen.
Yes sir.
Just have a look here. Can you able to see my screen?
Yes sir. Yes sir.
Yeah, I think we should start.
Yes.
Very good morning to all of you.
Good
So
morning, sir.
good morning. Yeah. So we'll start our
Sir, there is
session.
one doubt,
Yeah.
sir. Sir, you have shared the drive link, and there are too many softwares in that. Exactly which one we have to
Deep
download?
trace software you require.
Suyesh
Deep
already
trace.
had sent the message on the group. Deep trace you have to install.
Have
Suyesh,
you
open
installed
the
deep trace
link.
software? If not, maybe after 20 minutes, we'll take small break of 5 minutes. Within 5 minutes, you can install that software.
Okay, sir.
So what we'll do, we'll start with the session. After 20 minutes, we require actual software. So this workshop is on PCB design using deep trace software. So I will discuss about both types of PCB, single-sided PCB design and double-sided PCB design. Let me introduce myself. I am Dr. A.B. Kakde. I am working as Dean R&D and also Associate Professor in the Department of Electronics and Telecommunication at Rajaram Bapu Institute of Technology, and I am also founder of my startup Anand Techno Creations. So content of the training program, I will talk about PCB design guidelines. That is how to place the components, where to place connectors, where to place integrated ICs, where to place microcontroller in the PCB. So PCB design guidelines I will discuss in short. After that, we'll have case study of single-sided PCB design, and then we'll have double-sided PCB design. So in double-sided PCB design, I will take case study on 4-key touch switch. You will be excited to use touch switch in your capstone projects. So this is the peak development board that we are going to design. So we'll not only design its PCB, but you will also mount components, do soldering and testing, and you will run some programs on this peak development board. So I will talk about in detail this peak development board. In this slide, you will we will see both sides of the peak development board, that is component side and trace side. This slide shows PCB without green mask. Let us compare PCBs in two slides. In this PCB, you will see there is coating of green color on the soldering side. There are two applications of this green mask, and this is the PCB without green mask. This PCB we have fabricated in our PCB lab. Now, what is the purpose of green mask? In automatic soldering, green mask is must, especially when wave soldering. In automatic soldering, there is one method called wave soldering. So, wave of the molten solder touches the trace side of the PCB, and if green mask is not applied, this soldering will be applied on each and every trace, and there will be wastage of trace. In addition, in the absence of green mask, there is issue of short circuit. That is when thick layer of solder is applied on the nearby traces, then there is short circuit. You will see on the bottom side of this PCB, there are copper lines. Here afterwards, I will call this as trace. It is called copper trace, but I will simply call it as trace. So trace is made up of copper layer, and purpose of trace is to connect different pads on the PCB. So first of all, understand what is the purpose of PCB. PCB provides mechanical support to the components. This is first thing. And second thing, it provides interconnection of components. So we do not require wires for connecting the components. So these wires are in the form of copper traces. Second application of the green mask is to protect the copper from oxidation. If green mask is not applied, this copper reacts with atmosphere and it causes oxidation. Although oxidation does not damage the copper permanently, because once oxide layer is formed on the copper layer, subsequently it is not oxidized. So without green mask also PCB works, but in automatic soldering, green mask is must. When you do soldering by manual method, then green mask present or doesn't matter. So that is the role of green mask. Now PCBs are two types, double-sided, single-sided, and even multi-layer PCBs are also used in some applications. So process of multi-layer PCB, that is more than 2-layer PCB design, is very complicated. So this is out of scope of this workshop. So I will talk about single-sided PCB design and double-sided PCB design. In single-sided PCB design, copper traces are present only on one side of the PCB, whereas in double-sided PCB, copper traces are present on both sides of the PCB. So this peak development board is single-sided PCB. That is, components are on one side and copper traces are on second side of the PCB. I will talk about this touchpad. Let me show you a photograph of touchpad. In one of my product, I have used touchpad, and this is designed using double-sided PCB. So you will see here design of double-sided PCB, and case study is 4-key touchpad. So some of you can make use of touchpad in your capstone project. That is, in upcoming years, if you are planning to do capstone project and if keys are involved in your project, then you can replace mechanical keys by this touchpad. So maybe in some of the applications, like if you want to operate switches in your home by touch, then you can design your own touchpad. So this design of touchpad will also be covered in this workshop. So in this slide, you will see both sides of the double-sided PCB. One side is the component side and another side is the touchpad sensors. So these touchpad sensors are connected to this sensing chip. This is capacitive sensing chip. I will talk about this chip later. So just I want to tell you about what contents I am going to cover. So let us understand where I use this touchpad, just one application, and then I will actually start the workshop. So last year, I have developed IoT-based saline monitoring and control system. Now, what is the need of IoT-based saline monitoring and control system? In healthcare organizations, this IV saline is set and monitored manually by doctors and nurses and other supervising staff. So many times, nurses are not able to spare enough time for each and every patient. So nurse may not give enough time to all patients. Especially when IV saline is given to the patient, once bottle gets emptied, many times there is issue of reverse blood flow. If nurse do not attend the patients on right time, and if saline bottle gets emptied, then there is issue of reverse blood flow. So this is major issue in hospitals. Secondly, nurse requires frequent visits to check saline level in the bottle in order to replace or stop the flow. During surgeries, saline must be given at proper rate. So accurate systems are not available to measure the flow rate of the saline. The reason is, as saline is given to the patient, contactless systems are required to measure the flow rate. So what is the objective of this system? Objective of this IoT-based saline monitoring system and control system is to pinch the saline pipe just before emptying the saline bottle in order to prevent the reverse blood flow. We cannot put the solenoidal valve in order to control the flow. The reason is this solenoidal valve requires sterilization each time, and that is quite difficult. So solenoidal valve cannot be used for controlling the flow. Second thing, ordinary flow sensors cannot be used for measuring the flow rate. This is another issue. Second objective is to provide continuous and accurate monitoring, that is flow rate and drop counting of IV saline without contamination of IV fluid. Whatever sensor you use, that should not come in directly contact with IV saline. Third objective is to provide central and remote monitoring of IV saline through standalone display model and IoT model. And last objective, eliminate human intervention in monitoring the IV saline. So these are some features of the IoT-based saline monitoring system which I have developed. Let me tell you, I have filed 2 patents on it. So features are like automatically pinches IV pipe. You know, pinching. I hope all of you know what is meant by pinching. Pinching म्हणजे पाईपला दाबणे, सलाईनची पाईपला जी दाबण्याचं ऑपरेशन आहे त्याला आपण पिंचिंग म्हणतो. So it automatically pinches IV pipe when IV bottle is about to finish. So when 5 to 10 ml saline is left in the bottle, system senses it and it pinches the IV pipe. So automatic pinching of IV pipe prevents reverse blood flow. It gives real-time indication of saline flow rate in ml per minute and drops per minute. Accuracy of drop counting is 100%. So drop counting is 100% accurate, whereas flow rate measurement is around 98% accurate. We have also developed mobile app. So data of saline given to multiple patients is available in one mobile app. So if system is connected to 100 IV bottles. So information of all 100 IV bottles can be monitored in one mobile app. It gives alert when flow rate exceeds set high threshold. System gives alert when flow rate falls below set threshold. It also gives alert before emptying the saline bottle. Real-time indication of amount of saline left in the bottle. Same system is useful for different saline fluids, including blood. Nurse calling system is also given in the system. So one button is given in the system. If patient touches that button, then that is reflected in Android app. Minimizes frequent visits of nurses to patient for checking the saline level. It is available in two models, without IoT and with IoT. In IoT model, above parameters can be monitored in mobile app or desktop app for multiple patients simultaneously. No contamination of IV fluid, as there is no any direct contact of fluid and system components. We have used touch panel to control system. So I am going to talk about this touch panel in this workshop. 2 patents have been filed on the proposed invention. System has warning system that alert the medical staff using buzzer or mobile phone IoT. No need of specific IV bottle. All the bottles currently present in the market can be fitted on the system. Provide indication on detection of stopping of IV fluid. Many times what happens is that even though enough quantity of saline is present in the bottle, and because of some reason there is sudden stoppage of the IV fluid, so that is also detected in the system. So this is the prototype of the system developed. You will see there is pinching mechanism. So IV pipe is passed through this pinching mechanism, and this pinching mechanism pinches the IV pipe just before emptying the bottle and prevents the reverse blood flow. So this control panel is shown separately on the right hand side of your screen, and you will see there is touch panel. So this control system has touch panel, and there are 4 touch buttons. Just by touching these buttons, entire control system is controlled by operator. So this touch sensor is on the other side of the plastic cover. So let us see, I will show that as well. So this is the Android app, screenshots of the Android app developed for the IoT based saline monitoring system. You will see this app is developed for 5 beds. So if you touch, for example, bed number 8, another screen will open, and that will give information of that IV bottle. That is at what rate saline is given to the patient. For example, 22 drops per minute. Flow rate is 3.04 ml per minute. Quantity left is 204 ml. Quantity left in percentage 82%. At 3.04 ml, this 204 ml will take 67 minutes to finish. Then other status, like what type of bottle is connected, saline is finished or not, flow rate is proper or improper, saline monitoring is on or off, patient request is raised or not. So all this information is available in this mobile app. And we have tested this in ICU of Krishna Hospital, Karad. So field trial is also conducted. So this is the PCB use, touch panel PCB use in the IoT based saline monitoring system. So total 4 keys are there. This chip supports total 7 keys. So we need only 4 keys. So we design this PCB only for 4 keys. So we can go up to 7 keys. This touchpad design, this shape of the sensing area can have arbitrary shape. It can be rectangular, it can be square, it can be circular, it can be oval. Any shape can be used. As this touchpad is operated by our fingers, it makes sense to have shape of the sensor circular. I have done around 5 to 6 iterations. In the datasheet of this capacitive sensing IC, proper dimensions of sensors are not mentioned. So by trial and error approach, I have optimized these dimensions. So there were around 6 iterations in finalizing the touch panel PCB. So in this workshop, without any iteration, you will understand optimum spacing of the touch panel. So as I already said, this is the plastic cover on the front side of this control panel. So I have put here sticker. So these stickers have circular markers. So these actual metallic sensors on this touch panel PCB and this sticker, they overlap. So this sticker is placed on the plastic cover, and the other side of the plastic cover, this touch panel is mounted from inside. So in between this touch sensor and sticker, there is plastic wall. So this sensing takes place through even plastic wall. So that is the accuracy of this touch sensor. So you will see here from inside, this is the inner side. From inside, this PCB is placed like this. Now we'll start actual PCB design. So before we use the software, let us understand some important terms used in PCB design. So PCBs available in the market have different thickness of copper layer. So some units used in PCB design are like unit of mass used in PCB technology is ounce. So some PCB manufacturers, I'm talking about blank PCBs. So in blank PCBs, thickness of the copper is sometimes not given in microns. It is given in ounce. So ounce is unit of mass. Ounce is abbreviated as OZ. This 1 ounce is equal to 28.34 grams. So if you go through the data sheet of the blank PCB, some manufacturers mention thickness of the copper in terms of mass. And from the mass, you can calculate what is the thickness. So this mass is given over a specific area. For example, if 1 ounce copper is applied on, let's say 3 feet by 3 feet PCB, then you can calculate what is the thickness. Then 1 mil is equal to 0.0254 millimeters. It is 25.4 micron. 1 inch is 2.54 centimeter and 25.4 millimeter. Because copper trace width is mentioned sometimes in millimeters or in mil. We'll do all calculations in millimeter. So PCB material and PCB types. In market, two types of PCBs are used. PCB made up of FR4 material. FR stands for fire resistance, and there are different categories in FR4 PCBs like FR4 to FR10. So FR4 PCB is glass reinforced epoxy laminate sheet. So PCB basically consists of non-conductive material. It is also called substrate. On this non-conductive material, thin layer of copper is applied. So this thin layer of copper is applied on one side of the PCB or on both sides of the PCB. So if you are designing double-sided PCB, you select a blank PCB having copper layer on both sides of the substrate. And if you are designing single-sided PCB, it makes sense to purchase PCB having only copper layer on one side. So glass epoxy PCBs are used in most of the applications, but in low-cost applications, one can use paper phenolic PCB. This paper phenolic PCB, there are three types, FR1 to FR3. These PCBs are very cheap, maybe at the 50% cost of FR4 PCB. So these paper phenolic PCBs are very cheap, but they are more brittle. They cannot withstand more vibrations. And if you do desoldering, while desoldering, there is more chance of damage to the copper traces. So paper phenolic PCBs are also called paper PCBs. They are least expensive, 50% cost of FR4 PCB, but their quality is not good. So some electronic product manufacturers make use of paper PCB in order to keep product cost at low. There are some kind of PCBs called Teflon. These PCBs are very expensive and they are used for microwave applications, for designing micro antennas, micro networks. This let me tell you, this FR4 PCB cost around 250 rupees per square feet, whereas this PCB is manufactured by Rogers Corporation USA. They cost around 12,000 rupees per square feet. See the huge difference. FR4 PCB cost only 250 rupees per square feet. I'm talking about blank PCB. This blank PCB that you are seeing in this slide, whereas these Teflon PCBs manufactured by Rogers Corporation USA, which are used for high frequency applications, they are very expensive, cost around 12,000 rupees per square feet. The property of this PCB is their low dielectric loss. Their loss tangent is very, very small, and such PCBs are used for high frequency applications. So this FR4 PCB has higher loss at microwave frequencies. So FR4 PCB is not suitable at microwave frequencies. PCBs, as I already said, single layered and multi-layer PCBs. So in multi-layer PCBs, number of layers can be greater than 2. Can be equal or greater than 2. PCB copper thickness. So copper thickness of PCB can be specified directly or as a weight of the copper per area. So I already told you that some PCB manufacturers, they give copper thickness in terms of weight of copper per area. So 1 ounce per square feet is 1.4 mils or 35 micrometer thickness. So most of the FR4 PCBs available in the market, they have 35 micrometer thickness. For high current applications, if your PCB traces required to carry higher current, then 35 micrometer thickness is not enough. So in high current applications, one can use copper thickness, PCBs with copper thickness of 70 micrometer or 105 micrometer thickness. I will also talk you about how to increase current rating of PCB having 35 micrometer thickness. Now when PCB is actually fabricated, after designing the PCB in software, PCBs are actually fabricated by PCB manufacturers. So while machining operation, this thickness, 35 micrometer thickness, may get reduced to around 28 micrometer to 30 micrometer. This is because while PCB fabrication process, there is scrubbing operation. Oxide layer is formed on the PCB. To remove that oxide layer, usually PCB manufacturers pass the PCB through scrubbing machine to remove the oxide layer. So with the help of motorized scrubber, oxide layer is removed. And as you know, scrubbing operation reduces the copper thickness. So this scrubbing operation takes twice while PCB manufacturing. So that's why this thickness of the substrate may further, thickness of the copper layer may further decrease. Conductivity of copper, it is 5.96 into 10 raised to 7 Siemens per meter. Copper is prepared for PCB because it has good soldering property. And second thing is, it is easy to apply copper layer on dielectric substrates as compared with other materials. Melting point of copper is 1084 degrees Celsius and density of copper at ambient temperature is 8.94 per cubic centimeter. Then common words used in PCB design. While designing the PCB in software, I will talk about these common words. Solder mask. The green color which is applied on PCB is called solder mask. As I already told you, purpose of green mask. In automatic soldering, solder must be applied at right places on the PCB, and right places are pads on the PCB. All components are soldered to the pads, whether it is resistor, whether it is IC, whether it is capacitor. So components are soldered on the pads. So in single-sided PCB, components are placed on one side of the PCB and their legs are passed through the holes. And these holes are at the center of the component pads. So soldering is applied on one side and components are placed on other side of the PCB. So these pads are made up of copper lands or made up of simply copper material. Then there is copper layer. Usually, instead of designing PCB like this, let me show you once again this PCB. In this PCB, there is no copper pore. That is, you will see only copper lines. In order to minimize effect of interference, many electronic product manufacturers, what they do is, the copper, I have removed copper from unwanted portions here. So what can also be done is, we can also pour here copper. In the blank portions here, we can pour copper, and that is called copper pore. and this copper pore is connected to ground. So you will get here more ground area. So that way we can minimize effect of interference. So I will talk about effect of interference later. So in this touch panel PCB, you will see there is copper pore. Under this green color, there is copper. And in this portion, look at the cursor I am moving here. From this portion, copper is removed. And again, this area which look like silver, shiny area, is also made up of copper, and it is coated with tin layer. And remaining copper is coated with green mask. So in this PCB, I have shown here small copper layer pads. These conducting lines made up of copper are called traces. Copper trace or simply trace. Silk layer. In silk layer, what is done? This text is printed. This printed text is printed using silk layer. This text is also called legends. So silk layer, we have solder mask, trace, pad, and copper layer. There is one more word used in double-sided PCB, and that is called via. So I will talk about via at the time of PCB design. So purpose of via is to interconnect copper traces on both sides of the PCB in multi-layer PCB. Trace width calculation. This trace is nothing but wire on the PCB. So all the traces on the PCB function as conducting wire. And the role of trace is to interconnect the components. So purpose of the trace is to interconnect different components, terminals of different components together. So traces plays a role of wires on the PCB. And this trace has width. This trace has width. Now what should be width of trace? So width of the trace mainly depends upon current capacity. If trace required to carry larger current, then we require larger trace width. So we'll see how to calculate the optimum width of the traces. So trace width mainly depends upon current carried by trace and minimum fabrication accuracy. So for lower trace width, very precise fabrication facility is required. The PCB where I fabricate in Kolhapur and Pune, they have minimum fabrication accuracy of 0.3 mm. So most of the PCB manufacturers located in our area, they can fabricate traces having width as small as 0.3 mm. Sometimes they may go up to 0.2 mm, but below 0.2 mm it is difficult to fabricate. However, with high-end technology, traces much smaller than 0.2 mm can be fabricated, especially in LCD display. Let us have a look here. In this LCD display, the lines which are here, their width is very, very small. It is in microns. So fabrication of such PCB requires very high-end technology. Now I will talk about online trace width calculator. Before that, ampacity. Ampacity is defined as maximum amount of electric current a conductor or device can carry before sustaining immediate or progressive deterioration. So for example, if current carrying capacity of trace is half ampere and if you pass 1 ampere current through it, what will happen? It will heat up and eventually it will burn. So trace width depends upon how much current is flowing through the trace. So I will give one example how to use online trace width calculator. So in Google, you just type trace width calculator. Plenty of online trace width calculators are available. See, once we purchase PCB, FR4 PCB with 35 micron thickness, information is given here. Input is the current. For example, for 10 ampere current, thickness will select unit of mm. Micron, sorry. Now give input. The thickness of the copper layer on the PCB, for example, 30 micron. What I told you, during machining operation, 35 micron thickness of the copper may get reduced to 30 micron because of scrubbing operation. So 5 ampere current, temperature rise. When higher current flows through the PCB traces, there is rise in temperature. So how much temperature rise we can allow, that must be entered here. So safe temperature rise is 10 degree. If you allow larger temperature rise, then copper traces will heat up much. So in standard practice in industry is to consider 10 degree temperature rise. Then ambient temperature. Always enter worst case ambient temperature. For example, 48 degree. Trace length is not important here. Trace width is more important for us. Then required trace width. How much trace width is required for 5 ampere current? For 5 ampere current, you will see here 8.39 millimeter trace width is required. So just note down this point. Open any online trace width calculator, and what should be your input? How much micron thickness is used in copper layer and how much current you want to pass through the trace. So for 5 ampere current, the required trace width is 8.39 millimeter. Resistance is also given here. The resistance of this trace for 1 inch length is 0.00194 ohms. Voltage drop is also mentioned here. 0.00968 volts. Power loss is given. This is for internal layer. In multi-layer PCB, if your layer is inside, then you require larger trace width because the heat generated in the traces is not dissipated in surrounding medium. That's why in multi-layer PCB, if higher current is flowing through the traces which are internal to the PCB, then we require larger trace width. But if layer is external, then the required trace width is 3.23 millimeter. So very small trace width is required for external layers. I hope you have understood the difference. For traces on the internal layers, larger trace width is required. And if traces are directly exposed to the surrounding air, then lesser width is required. You know, current carrying capacity depends upon cross-sectional area. Let me talk about here. Current capacity of any conducting wire depends upon its cross-sectional area. So if you take simple example of conductor, so if you take example of conductor, this current carrying capacity of conductor depends upon cross-sectional area. Larger the cross-sectional area, larger is the current carrying capacity. Now in case of copper traces on the PCB, thickness of the copper layer is fixed. To increase current carrying capacitor, the only parameter under our control is width of the copper trace. This is copper trace, for example. So thickness of the copper layer. Thickness of the copper layer is already fixed. So this is thickness of the copper layer. Let thickness of the copper layer be T. So thickness of the copper layer is fixed and it is 30 micron after machining. So cross-sectional area of the copper traces, as thickness is fixed, can be changed by changing the W. So cross-sectional area is width of the copper trace multiplied by thickness. So by properly selecting the width, we can control the current carrying capacity of the width. Now when current carrying capacity required is very small, maybe in microamperes, then required dimension can be in microns. As I already told you, the PCB fabrication facility, just a minute. So here, W is the width of the copper trace. This is copper trace. So cross-sectional area is equal to width into thickness, and thickness is already fixed at 30 micron. So in PCB manufacturing process, which is available nearby, maybe in Pune, Kolhapur, they can
fabricate
traces with minimum W is equal to 0.2 millimeter. So below 0.2 millimeter, it is difficult to fabricate with the current PCB manufacturers available in our area. So what I do is, when we have enough space on the PCB, I usually use W equal to 0.6 mm to 0.8 mm, this range. I get a better accuracy. But in some applications where I am using SMD ICs, I don't have choice of going for 0.6 mm. So there I use 0.3 mm trace width. And in some applications where traces needs to carry more current, there I use 2 mm, 3 mm trace width. So these are the general guidelines. Now next thing is, before we actually start the workshop, next thing is how to place the components. There are two methods. Draw the schematic in PCB design software and convert schematic into actual PCB layout. I initially tried in 2013. I have drawn the schematic of the circuit and I converted that into PCB layout. But there I do not get good design. That design is very messy kind of thing. Traces are not properly routed. And second thing is placement of component is also not optimum. So thereafterwards I started designing PCB manually instead of using schematic and conversion of schematic into PCB. So I prefer to use manual routing, and in this workshop also I'm going to conduct the session of PCB design using manual routing. Now what you need to design is, once your circuit is finalized, unless and until your circuit is not finalized, you cannot think of PCB design. So once your circuit is finalized, you decide placement of components, that where you want to place microcontroller IC, where you want to place switches, where you want to place connectors, where you want to place signal conditioning circuit components. So general rule is your microcontroller must be at the center of the PCB. There is reason for it. Your microcontroller must be at the center of the PCB. Now what is the reason for it? What is role of microcontroller in any product? What is role? You can write role of microcontroller in any product. You can write in chat box. Response in chat box. Yeah, Siddhant Jain answered this question, to control the signals. Anything else? Yes, another right answer, to take inputs, give output, and to process information. Very rightly answered. So role of microcontroller is to capture the signal from responses, process it, and take corrective actions or control some devices. So why to place controller at the center? These microcontrollers have port pins, and these port pins we interface with different peripheral devices and signal conditioning circuits. So output of the signal conditioning circuit is input to the microcontroller, and devices connected to the microcontroller pins are controlled through maybe directly or through driver circuit. So if microcontroller is on the one side, what will happen is that it is not possible to use pins on the one side of the microcontroller, because imagine this controller is on the edge of the PCB. In that case, we will not be able to use microcontroller pins on one side. So it makes sense to place microcontroller at the center of the PCB, because all peripheral devices, signal conditioning circuit can be connected to microcontroller from all sides. So this is DIP microcontroller in DIP IC package. It can be in SMD IC package. In SMD IC package, microcontroller pins will be available on all four sides. Let me show you that PCB, that package as well. Look at here. This is TQFP IC package, thin quad flat package. TQFP. T stands for thin, Q stands for quad. Quad means these IC legs are available on all four sides. Quad means four. So IC legs are available on all four sides of the IC package. That's why it is called quad. And this is thin quad, flat. This thickness is very small. That's why it is called flat and package. So microcontroller IC must be at the middle of the PCB. If you are using some kind of connectors, the connector must be given at the edges of the PCB. So look at here. This green connector is called here terminal block. We connect wires to the terminal block with the help of these screws. So these terminal blocks in the form of connector must be at the edges. In the PIC development board, I have given here bug strip made up of male type connector for directly connecting the LCD display. So what is the purpose of giving bus strip directly here is, if I do not connect port pins to this bus strip, what I need to do is I require jumper wires. And for LCD interfacing, there are 8 data pins and 3 control lines. So total at least 11 jumper wires are required for connecting LCD display. So in the PIC development board, which I am going to teach you, microcontroller port pins are directly connected to this connector. So we can directly insert this female connector on the LCD display to this male connector. So we do not require jumper wires. Problem with jumper wires is, if contact is not firm, you will not get proper response on the LCD display, even though your code is correct. So you will lose a lot of time in troubleshooting the problem. So in this PIC development board, which I have developed for my department, I use required components. You can add other components as well, but minimum required components I have added on the development board. Like we have here pull-up register. if you want to do some kind of experimentation with interrupts, and if you want to use microcontroller port pins with pull-up register, then look at here. This is pull-up register. So pull-up register I will talk later, and this is in the form of register network. So many of you might have not seen register network. So what is register network? Let me uh, discuss here itself. Microcontroller, suppose this is microcontroller port pin. This is microcontroller IC, and these are GPIO pins. Let us take any one pin. This microcontroller has RB7 pin. If you want to connect pull-up register, then what you need to do is you need to connect 10K register here, 10K or 20K. So this, whenever we use pull-up register, usually that pin is used as input pin. This is input pin of the microcontroller. So pull-up registers are used with some kind of sensors and switches. So if you want to detect key press, for example, so what we need to do is we need to connect one pull-up register or pull-down register. That depends upon application. So as long as key is open, this microcontroller pin is at logic 1 level. This is at logic 1 level. When this key is closed, this pin is at logic 0. So just by scanning this pin or through interrupt, we can detect what is the logic level of this pin, whether it is at logic 0 or logic 1. So in such applications, we require pull-up register. So there are some sensors which also require pull-up registers. Now in this development board, these lower 4 pins, that is RB0, RB1, RB3 and RB3. These 4 pins are connected to this pull-up register, and this pull-up register is controlled through these 2 pins. When these 2 pins are shorted, this pull-up register gets connected to the 4 pins, and when these 2 pins are open, then pull-up register is disconnected. So with the help of putting short circuit here, if you put short circuit, pull-up register gets connected to lower 4 pins, and if you remove this short circuit, if you keep these two pins open, then this pull-up register gets disconnected. And for pull-up register, I use register network. Now what is register network? So let us understand this component because we are going to use it in our development board. So register network. We can use 4 separate registers for application of pull-up register, but it requires more space on the PCB. With the help of register network, we can minimize space on the PCB. So register network are available in 5 pin and 9 pin. So in PIC development board, we have used 5 pin register network. This register network internally consists of 4 registers. These register networks are available in 10K, 4.7K, 20K and so on. So 5 pin register network consists of total 4 registers. One end of all registers is shorted together, and its common terminal is also taken out. So you will see there are total 5 terminals, 1, 2, 3, 4, and one is common terminal. So total 5 terminals are available in 5 pin register network. So if you select 10K register network, it will have all 4 registers of 10K value. Values will be 10K. How many terminals are there? Total 5 terminals. Out of 5 terminals, 1 terminal is common. And this common terminal, visually we connect it to 5 volt. So in less space, we can connect more number of registers. In 9 pin register network, total 8 registers are there, and common one will be common terminal. I have not taken separate photograph of the register network. So let's see it on the Google. NK register network. It look like this. This is 9-pin register network. Look at here. This is 9-pin register network. All register networks are marked with dot. This dot indicates common terminal. That is on the left hand side of this register network. There is common terminal, and remaining are the 8 terminals of 8 registers. Similarly, in 5-pin register network, there will be 5 terminals, and there will be common terminal is always marked with dot. These register networks are available in SMD and non-SMD versions. Like here, this is the SMD register network. 103 indicates it is 10K register network. So this is register network. Now for controlling, sorry, not controlling, to debug your code, when you write C code, to check whether your code is running properly on microcontroller or not, you can very easily check by making the LED on and off. So you can write simple program to test your code, and through the code, you can switch LED on and off. So that way, you can check correctness of your code. So what you can do is now, you can, with the help of jumper wire, for example, you will see RB0 pin here. This is RB0 pin of microcontroller. So with the help of jumper wire, you can connect the jumper wire to one of the connector of LED. So what I have done here is, these are 4 LEDs. One terminal of LED is connected here, like this, one end. And another end is connected to this current limiting resistor of 2.2K value. And this other end is grounded here. That means anodes of all 4 LEDs is available on this 4-pin connector. Anodes here. So if I connect this RB0 pin of microcontroller to this port pin, then by writing program, I can toggle the RB0 pin. I can make RB0 pin on and off with some delay. So that way we can make LED on and off. So we can verify whether your code is running properly or not. You can add some LED on off condition in the code, and you can verify it. So that is the purpose of adding LEDs on the PCB. For writing code to control some kind of switch, I have given only one switch here. You can connect external switch 4x4 keypad matrix to port B, for example, here. So you can connect external keypad to this connector. You can use any one connector, but advantage of using this connector is, for keypad we require pull-up register, and this pull-up register is available already here. So that's why we use pull-up register. Then other components on the PCB, and then we will discuss actual PCB design. So what I have done is, I have given here motor driver IC. This IC is ULN 2003. All of you know this motor driver IC, ULN 2003 IC. So with the help of this IC, we can control either stepper motor or DC motor. So this is motor driver IC. Similarly, for connecting some additional peripheral devices, different voltages are available on this connector. Like this is ground connector, it is mentioned here, ground. This is 12-volt connector, and here you will get 5 volt. So if you want to give 5 volt, 12 volt to some other peripheral devices, then those voltage levels are available on this connector. Programming pins are available here. These are programming pins. To program PIC microcontroller IC, what we need is, we require programming pins. So ground, MCLR, VCC, PGD, and PGC. These pins are available here for programming purpose. Programming pins. And program is serially downloaded into the microcontroller. Serial communication. Program is loaded into microcontroller flash memory through serial communication. It is synchronous serial communication, PGD and PGC, program clock, program data. There are two pins here, PGD and PGC. So these PGD and PGC pins are connected to RB6 and RB7 pins of microcontroller. These RB6 and RB7 pins are multiplex for programming application. This is reset switch. Reset switch. This is preset. With the help of preset, we can vary voltage from 0 to 5. And output voltage of preset is connected to RA0 pin of the microcontroller directly. RA0 pin. So while using the PIC development board, this analog pin of the analog RA0 is analog pin. It is directly connected to output of the preset 0 to 5. So please note that this pin must be always configured as input. Your RA0 pin must be input, otherwise your port pin will damage. For example, if you configure RA0 pin as output and if you set preset to 5 volt, then large amount of current will flow through the port pin and it will get permanently damaged. So while using this PIC development board, precaution must be taken to configure RA0 pin as input in your program. Please follow this instruction and note down somewhere. Your RA0 pin must be configured as input. Otherwise, that particular port pin will get damaged. We have here LCD display. This connector is for, it is mentioned here, LCD display. So which pins are connected where, I will talk later, or maybe directly you can understand instead of later. What I have written here, this lower pin is ground. It is VCC, contrast, register select. Register select pin is connected to RC1 pin of microcontroller. Then read write pin of the LCD display is connected to RC2 pin of microcontroller. Enable pin of LCD display is connected to RC3 pin of microcontroller. And then we have 8 data pins of LCD display. These 8 data pins are connected to port D. These pins are connected to port D. Like DB0 pin of LCD display is connected to RD0 and DB7 is connected to RD7. This DB0 is connected to RD0 and DB7 is connected to RD7 and so on. So this RD7 pin is connected here. You will see on the lower side. This is LCD display and some pins are, you see here, not some, all control pins and data pins are directly connected to microcontroller. See this trace. Let us zoom in. This is LCD display. LCD display connector. LCD display connector. So these data pins and control pins are connected to microcontroller port pins this way. You will see these conducting tracks. For serial communication between external peripheral device, maybe GSM modem, maybe if you want to interface node MCU, then for serial communication, RC6 and RC7 pins are available here. So RC6 and RC7 pins are used for serial communication. Okay. These 4 pins are input pins of the motor driver IC. Input pins of motor driver. Input pins of motor driver IC. And these are output pins of motor driver IC. So you can directly connect maybe DC motor, stepper motor and control it. So this is information of PIC development board. Just one important thing, for controlling contrast of the LCD display, contrast must be proper. Some PIC development manufacturers, they give preset for controlling the contrast. I have not given preset. Instead of preset, what I have done is, you can note down this important point. I have connected 2.2K register for controlling the contrast, fixed register. Wholesale price of fixed register is only 40 paise. So instead of using preset, what I use is fixed register of 2.2K value. And now where it is connected? This register is connected in between contrast pin and ground pin. You know, one end of this register is connected to the contrast pin. This is the contrast pin. And other end is grounded. This LED minus, it is written here. This other end is grounded. In this LCD display, last two pins are LED minus and LED plus. All LCD display have LED on the back side. That is called backlight LED. And purpose of this backlight LED is to make the characters readable in the absence of ambient light. So character looks bright in the presence of backlight. So purpose of this LED is to make characters readable. So this LED has anode and cathode. Cathode is connected to LED minus and anode is connected to LED plus. So just note down important point. LCD display has contrast pin. In between contrast pin and ground, I have connected 2.2K resistor. So through trial and error approach, I find out optimum resistor for contrast, and it is 2.2K. So I never use preset for controlling contrast of the LCD display. I use always fixed resistor of 2.2K for controlling the contrast. So this is detailed information of this peak development board. I think only power LED is left. So this is power indication LED, whether power is available on peak development board or not. So output voltage of this 7805 regulator. This is 7805 regulator. Your controller works on 5 volt. So 7805 regulator. This is filter capacitor on the output side of 7805 regulator. And 5 volt is connected to this resistor. Then it is connected through LED, and one cathode of LED is grounded. So when power is applied to the development board, this LED starts glowing. This is bigger size LED, 5 mm LED. And these small LEDs are 3 mm LEDs. And this is 12 volt jack. So you must connect here 12 volt jack pin. So what I have done is, when you connect 12 volt jack pin here, same voltage is made available on this connector, 12 volt connector. And output voltage of regulator is available on this 5 volt connector. So having discussed online calculator, next is how to increase current carrying capacity of the trace. If some application requires very high current carrying capacity, so most of the PCB manufacturers, they buy FR4 substrate with 35 micron copper. If you go for 70 micron or 105 micron copper thickness, then those PCBs are bit expensive. So what we can do is, where we cannot give larger width on the PCB, because if you go for larger width in order to increase the current capacity, the problem is, for larger width you require more larger size of the PCB. So cost of the PCB will increase, and at the same time your PCB, if your PCB size increases, that also causes increase in size of the product enclosure. So your overall size of the product gets increased if your PCB size gets increased. So another way to increase the current carrying capacity is to apply thick layer of solder on the copper traces. So what you can do is, at the time of PCB manufacturing, you ask PCB manufacturer not to put green mask on the copper traces where larger current is flowing. And on such copper traces, what you can do is, you can apply thick layer of the solder material, or you can put small copper wire on the copper trace and apply solder. So you can see here, this is the portion where around 2 ampere current is flowing. And what I have done here is, I have just applied small copper wire on this copper traces and I have soldered it. So this way we can increase current carrying capacity. You can see here there are relays, and through relay sometimes 2 ampere current flows, sometimes it may go up to 4 ampere. So what I have done is, to increase the current capacity of these traces, I have put copper wire and I have soldered it. So this way we can increase current carrying capacity without going for 70 micron or 105 micron copper thickness. So basically, just have a look at this table, trace width calculation. Temperature rise is mentioned 10, 20, 30. We have already discussed one example with online calculator. So let's just go through this table. Copper weight is given here. Copper weight is ounce per feet square. So three different examples are given: 10-degree temperature rise, 20-degree temperature rise, and 30-degree temperature rise. As I already mentioned, industry practice is 10-degree temperature rise. So what is the copper weight? Half ounce per square feet, 1 ounce per square feet, and 2 ounce per square feet for 10-degree. So same thickness is taken for 20 and 30-degree temperature rise. Now trace width is given in inches in this table. Trace width in inches and maximum current in amperes. So let's take first example. I think I must use annotator. This annotator. So this trace width is given here in inches. What is the current carrying capacity when copper thickness is 1 ounce per feet square? Maximum current is half ampere. And what is the trace width? It is 0.01 inches. This current carrying capacity increases to 1 ampere when thickness of the copper is increased to 1 ounce per feet square. This current carrying capacity of same width increases to 1.4 ampere when thickness of the copper is further increased to 2 ounce per feet square. The thickness of the copper layer on the PCB has direct impact on current carrying capacity. Now another thing is, when this width of the copper trace is doubled, this example 0.20, current carrying capacity is not doubled. Look at here, it has not doubled, it has become 0.7 ampere. It is increased from 1 to 1.3 ampere. It is increased from 1.4 to 2.1 ampere. It is not doubled. Now compare same values with higher temperature rise. If you allow 30-degree temperature rise, then look at here. These three values. Compare these three values with these three values. These first three values are for 10-degree temperature rise, and these last three values are for 30-degree temperature rise. So if you allow larger temperature rise, then we get larger current carrying capacity at the cost of increased temperature of the copper traces. So if you go for higher temperature rise, copper traces may get damaged. So standard practice is to consider 10-degree temperature rise. It is safe value. So temperature rise means how much hotter the trace will get with current flowing in it compared to without. You have to decide how much temperature rise your board can handle. 10 degree is very safe number to use for just about any application. Then another important term used in PCB design is footprint. Now what is footprint? A footprint is also called land pattern. Footprint is also called land pattern. Is the arrangement of pads in surface mount technology or through holes in through hole technology used to physically attach and electrically connect a component to a printed circuit board. The land pattern on a circuit board matches the arrangement of leads on a component. Example, you will see this is PCB and this is land pattern on the PCB. Land pattern. This land pattern exactly matches with footprint of components. So in PCB softwares, land patterns or foot patterns of many standard components is available. So with the help of these land patterns, we can directly select them. And if land pattern is not available, we can manually create it. manual creation of LAN pattern is very time consuming. So I will also talk about how to create manual LAN pattern and how to make use of standard LAN patterns available in the library of the software. So on the right hand side, you will see different LAN patterns for different IC packages. So look at this. This LAN pattern is used for through-hole components. Here holes are drilled. So component is placed from another side and solder is done on this pad side. So where holes are drilled, this LAN pattern consists of LAN patterns for through-hole components. And you will see these LAN patterns. These LAN patterns are used for SMD components, surface mount devices. Surface mount devices does not require drilling a hole. So SMD patterns do not contain holes for mounting the components, whereas through-hole components requires LAN patterns with hole. This is pinout of PIC18A 4.20. I propose to use this microcontroller in your PIC development board. However, you can use any microcontroller from PIC18F series having 40 pins in the same development board. So this is the pinout. As I already told you, for programming purpose, RB6 and RB7 pins are used. So RB6 pin is multiplexed with program clock operation in programming the device, and RB7 pin is multiplexed with program data. PGT stands for program data. PGC stands for program clock. Program clock, program data. And this MCLR pin, it is also called reset pin. MCLR means master clear reset. This MCLR pin is multiplexed with a VPP and RE3 application. So VPP pin is again used for programming application. While programming the device, this pin function as VPP. And in other than programming, this pin can be used as reset pin or RE3 pin of the portee. This is the thin pad plaque. This is pinout of motor driver IC. You know, motor driver ICs are used to increase current carrying capacity. Microcontroller port pin can give maximum current of 25 milliampere, but motors require current in the range of amperes, maybe 0.2 ampere, 0.3 ampere, 5 ampere, 1 ampere, and so on. So ULN driver IC provides larger current for the motors, DC motor or stepper motor. So it has input pins and output pin. It has one ground pin and it has one common pin. To increase current carrying capacity, what we can do is we can short circuit input side and output side. Current carrying capacity of individual pin on the ULN motor driver IC is 500 milliampere. What is current carrying capacity here? 500 milliampere. If you want to increase current carrying capacity of the ULN driver IC, what you can do is you can short circuit two input pins. Just short circuit two input pins and apply common control signal. Similarly, do short circuit on the output side and connect your motor or whatever device you have. So what happens here is now you will get 1 ampere current rating, 500 milliampere into 2. So total current rating becomes 1 ampere. Maximum current rating of individual pin is 500 milliampere, but after short circuiting two input pins and two output pins, current rating becomes 1 ampere. So before now we start a software session, what we need to do is just understand one important tip in this video. I have shot one video and some guidelines are given. Just understand those guidelines. I would like to know whether video is audible or not. Give me feedback. Just quick feedback from you.
No, sir.
Is video audible?
No, it is not audible.
Okay, okay. Let me see the settings. Checking here. Setting for sharing audio of the video. Just minute.
Excuse me, sir.
Yeah.
So while sharing screen, you will get the option for video and audio. So
Okay.
stop pressing.
So I will once again do it.
Okay, sir.
I'm not getting that option.
Sir, is this video available on a drive or in your PC?
It is on my PC.
Then it will be a problem, sir. It just only shares tab, means you can hear YouTube videos. Vaga.
So on my screen, I'm not getting option of sharing the audio.
No, sir. Then it will be not
So
available.
what we'll do, we'll have a break of 5 minutes. By that time, you install deep test software. After that, what I will do is I will share link on Google link on from the Google Drive, and maybe from your side you can share this video. Okay.
Okay, sir.
We'll have short break of 5 minutes and we'll resume. Can we start?
Yes, sir.
So can someone play this video? It is of 2 minutes. PCB.
Is it audible, sir?
PCB stands for yes, audible. Printed circuit board. Please play it in full screen. There are basically two types of PCB. Multi-layer PCB. This is blank single layer PCB. In single layer PCB, components are mounted on one side. This is component side of the single layer PCB, and this is conducting track side. Conducting tracks are also called PCB lands. This side components are soldered. This is blank PCB without components. This is same PCB where components are mounted. This is opposite side of the PCB where soldering is done. Second type of PCB is multi-layer PCB. In multi-layer PCB, number of layers can be greater than or equal to 2. So we'll see here,
please
this is double-sided PCB, that is two-layer PCB. On both sides, you will see conducting tracks. So components are mounted on both sides of the PCB. And soldering is also done on both sides of the PCB. This is double-sided PCB with components mounted. You can see these are capacitors, connectors, buzzer, SMD registers here. This is other side of the PCB, Wi-Fi chip, microcontroller, some other SMD ICs. Now let us understand how to design single layer PCB. Once you understand design procedure of single layer PCB, you will understand how to design multi-layer PCB. So in single layer PCB, open the DipTrace software and assume that you are facing component side of the PCB. Once again I repeat, you assume that you are facing component side of the PCB. Second assumption is you assume that PCB is transparent. Like I have taken here acrylic sheet, it is transparent. So assume that this is PCB and this side is component side and opposite side is track side. So I have here printout. Assume that these are copper tracks. So if I put this acrylic sheet here, I can see other side of the PCB. So with this assumption, we can design single layer PCB. Like if I put this actual PCB, on opposite side you will see there are conducting tracks. So when I rotate the PCB, what I get here? Mirror image. Like here, you will see this connector. This connector is coming now on this side. So if I put this PCB on top of this printout, this bottom side of the PCB will exactly match from this side. So by assuming PCB is transparent and facing the component side, we can design PCB in DipTrace software.
Hello, sir.
Hello.
Done, sir.
Yeah. Thank you. So now what I will do is let me check whether any point is left or not before we start the use of DipTrace software. Just one point. This ZIF socket. In this peak development board, the socket use, IC socket use is called ZIP socket. ZIF. It is abbreviated as ZIF. It is zero insertion force. So there is one lever given here. With the help of this lever, we can tight this IC or make IC loose so that it can be taken out. As zero force is required for inserting IC, it is called zero insertion force package. which is abbreviated as ZIP, ZIF. And this is ordinary IC socket where you need to apply force while inserting the IC. Component patterns. Once we start using deep test software and when we start actual design of the PIC development board, we need to select components from the libraries. So which components we require here? We require resistor, we require DC jack pin, we require electrolytic capacitor, we require 7805 regulator, we require PIC microcontroller IC, and so on. So what we'll do is, at the time of demonstration of the software, I will guide you how to select the components. And what we'll do is, we'll select components first, and then we'll interconnect them. So we'll select all components, like we'll select microcontroller, we'll select connectors, we'll select 7805 regulator, we'll select DC jack, and we'll start connecting them. So what we need to do is, as I already said, once you become experienced person in PCB design, once you become more mature, you will understand how to place the components manually, and then you can interconnect them. While interconnecting the components, you may require jumpers. Try to avoid the jumpers in PCB as far as possible. Whenever no option is left, we can make use of jumpers. In double-sided PCB, jumpers are not used. Instead of jumpers, static vias are used. With the help of static vias, we can jump over from one track to another track, another trace to another trace, and so on. This is heat sinkable sleeve. In PIC development board, it is not used, but let me tell you, this heat sinkable sleeve, when you join two wires together, these two wires must be electrically insulated. So what we can do is, we can either use insulation tape or heat sinkable sleeve. So heat sinkable sleeve, instead of insulation tape, if heat sinkable sleeve is used, what you need to do is, before soldering the two joints, insert the sleeve. After soldering, put it on the solder joint and apply heat. When you apply the heat, this sleeve shrinks and becomes tight. So that's why this sleeve is called heat sinkable sleeve. Maybe if time permits, I will show you small video about using heat sinkable sleeve. So this is about general information required for PCB design. Now what we'll do is, we'll open deep test software and actually start working on PCB design. So let me open the deep test software. So if you type deep test, or you may have icon on the desktop. So I don't have icon. So I have this deep test launcher. So when you click on the deep test launcher, you will have here 4 options. This dialog will appear on your screen. What are the 4 options available? Schematic capture, PCB layout, component editor, and pattern editor. So if you use schematic capture, you need to draw a schematic diagram of your circuit board, and then that can be converted into PCB layout. But I already told you that does not yield optimum design. So when you convert schematic into PCB layout, that does not yield standard PCB layout. It may not be proper. Connections will be messy. So what we'll do is, we'll directly make use of PCB layout, and we'll manually place components and manually interconnect them. So click on the PCB layout. This deep trace software is available in free version and license version. If your number of pads in design are limited to 300, then it works in free mode. If number of pads in your PCB design are greater than 300, then you need to buy license version. However, limited days trial version is also available, where number of pads can be greater than 300. However, that version is available only for 30 days trial. So once you open PCB layout software, you will come across this graphical user interface window. On the top side of this window, you will see ribbon, and ribbon contains different menus like file menu, edit menu, view, object, placement, route, and you will see also multiple components here, multiple tools for using the software. Look at the cursor position here, this icon. We'll frequently make use of this icon. What is this icon here? Place component. What you can do is, if you have a notebook with you, some important points, some important tools, you can note it down. This place component tool will frequently use in this session. Place component. Near the place component, here, there is one tool called measure. So if you want to measure width of the trace, length of the trace, distance between two components, you can make use of measure tool. Look at the cursor position. This is the measure tool. So what I will do is, as you are parallelly watching my screen, and I will also ask you to do hands-on. So simultaneously it is very difficult. So what we'll do is, I will place one component. I will also ask you to follow that step in your laptop. So I will wait for some time in between. So before I start laying out the components, just understand the different tools, and then we'll start laying out the components. So this is measurement tool. Place component tool. Look at the cursor position. What it indicates? Place pad. So if you want to manually add some pads, if you want to create land pattern of some component manually, then what we need is, we need pad. So we'll put multiple pads, we'll arrange them in one line, we'll arrange them in square as per requirement, and we'll design footprint of component if it is not available in library of the software. In double-sided PCB, we use static via. So by placing the static via, this icon will be clicked. Place static via. Place copper pore. This copper pore will use in PIC development board. So copper pore will be used after complete design of the PCB. Place board outline. Without board outline, we cannot make negative. So this icon of place board icon is available here. Place board outline. Some other tools we'll discuss later. Then another important tool is route manual. This route manual we'll frequently use for PCB design. Route manual. After that, edit traces. If you want to fine tune the PCB traces, then we'll make use of edit traces. So route manual and edit traces, these two tools we'll frequently use. Now what we'll do is, let me show you our PIC development board. What we'll do is, we'll first of all select footprint of PIC microcontroller. This IC is DIP IC, so we must select DIP IC package. We'll first of all select footprint of PIC microcontroller. And what I told you, that you assume that your PCB is transparent. What is first assumption? Through video I told you, assume that this PCB is transparent so that your track side is visible to you and you are facing component side. Assume that you are facing component side and your PCB is transparent so that copper traces are visible to you. So that is the assumption. So first of all, click on the place components, this icon. Look at my cursor position. Click on the place component. After clicking on the place component icon, this dialog will appear. In this dialog, you will see there is one button marked with libraries. And where is the library selected here? Patterns. What we want to select is component. Put patterns of standard ICs, standard regulators, registers is available in the library of this software. So which library you select here? Component library. Component library is selected. Under component library, different options are available like discrete components, discrete SMD components, symbols, antennas, batteries, buzzers, capacitors. So many footprints of so many components are available under this library. So now what you need to do is you select microchip company. Footprints of components developed by different companies are available, like Fairchild Company, Infineon, Intel, Intersil, Lattice, Linear Technologies, Maximum Integrated Microchip. We must select microchip company. Why microchip company? Because we are using PIC microcontroller, and manufacturer of PIC microcontroller is microchip. In our development board, there is PIC microcontroller, and manufacturer of PIC microcontroller is Microchip Corporation USA. So what we need to select? Name of the company, it is Microchip. Now we are using PIC microcontroller. So if I directly type letter P, I will see here different part numbers of PIC microcontroller. And what is our part number? PIC 18F4520. Just scroll down and select the part number. PIC 18F series. So many microcontrollers are available in the library. PIC 18F45. Ours is PIC 18F4520. Yeah, here it is. 4520. This is DIP-IC. Different packages are available. Look at here. This is SMD-IC package. This is no lead SMD-IC package. This is leaded SMD-IC package. And this is DIP-IC package. So which package is relevant to us? DIP-IC package, that is PIC 18F4520_P. So select this. After selecting this here, on the lower side of this dialog, you will see place button. Look at the lower cursor position. Click on the place. The cursor will change here. Cursor will change something like this. On the bottom side of the cursor, there is square. Cursor is changed. Now, if I click it on the editor window, this is the editor window of the software. If I click mouse, component is placed. You can place as many IC packages as you want. We need only one. So after placing IC package, if you need only one IC package, after that click escape button. So once you click escape button, this cursor will change and you will not be able to place further IC packages. So we need only one. So what I will do is I will select and delete additional ones. So this is IC package. So this is how we can select footprint of microcontroller IC from the library of the software. Now by default, dimension of these pads, this is DIP-IC package. If you put the cursor on it, I am putting cursor on it. It indicates pin number and name of the pin for some time. Look at the here. Pin number 40, RB7, KB13, PGD. So pin number is mentioned here. And pad size is also mentioned. What is the size? Outer diameter of this pad is 1.5 mm and what is drill size? 0.9 mm. So if you fabricate PCB with this dimension, you will not get enough area for proper soldering. So what I do is, in all my products which I have developed, I have modified this dimension. So let us understand. I think I must give small time to you so that you can follow this step. So what you do, you go through your deep trace software, click on the placed component icon and select the component. I will give few seconds to you. Let's follow this step. Do it in your laptop. I will wait for some time. And once you do this step, please acknowledge this in the chat box. Just after doing this step in your deep trace software, please mention in the chat box by writing done. Are you doing this activity? I will continue for another 10 minutes and then we'll stop. Remaining session will continue tomorrow. So have you followed the step? Select microcontroller IC in Depress software. Select its package and put it in the editor window. No one has replied yet. I once again repeat the step. Click on the place component. Look at my cursor here. It is on the top left hand side corner. Place component. This icon, place component. Click on it. One dialog will open. In this dialog, select component library. Select component library. After that, scroll down and select microchip company. This is microchip company. And then in components, on the right hand side of this dialog, inside the component edit box, select PIC18F 4.20 microcontroller. There are different IC packages, DIP, SMD. Select DIP IC package and click on the place button like this. So this IC package with footprint will be placed in editor window. I think some of you have done good. Now next, the dimensions of this pad are default dimensions. And according to my experience, these default dimensions are not good for proper soldering because you will get very small amount of solder area. So what we'll do is, we'll manually modify this pad dimensions. So what you do, you right click on any one pad. Right click on any one pad. One pop-up menu will appear. From this menu, select pad properties. I repeat this step. Right click on pad properties. Right click on any one pad and select pad properties. After that, one more dialog will appear on the screen. Click on the patterns pad properties. Click on this button. What is mentioned here? Patterns pad properties. One menu will pop up. Here default dimension is given. What is default dimension? 1.5 mm width. And what is height? 1.5 mm. And what is diameter of the hole? Diameter of the hole is 0.9. For zip socket, diameter of hole required is 0.9. However, if you use ordinary IC socket, for ordinary IC socket, required hole diameter is 0.7. To be on the safer side, I am keeping hole diameter 1 mm. Hole diameter is 1 mm. And hole dimension. What is the shape available? Shape availables are ellipse type of pad, oval type of pad, rectangle type of pad, and polygon type of pad. Okay. So what we'll do is we'll select oval type. Oval type pad is oval type of pad does not contain sharp corners. So that is the advantage of using oval type of pad. Now we'll modify width. Width is 1.8 mm and height is 2.8 mm. I have increased. So this is according to my experience. And on the lower side of this dialog, what you will see is one option, apply to all pads. So enable this. Apply to all 39 pads except first pad. It is rectangular. It will not be applied to first pad. Apply to all pads. click OK. Okay. Now you will see, I think square pad is also reflected. What I have done is I have increased dimension of the pad, so I get larger area for the soldering. And here hole diameter is 1 mm because zip socket, legs of the zip socket has around 1 mm diameter. Its diameter is 0.9 mm, but we need some gap so that it can be easily placed on the PCB. So this is how we can place the foot pattern of microcontroller IC, and we can modify the dimensions. So I request all of you to modify pad dimensions on your end. Take few seconds. So repeat this step on your side. And after doing, just mention done. So right click on any one IC pad, select properties. One more dialog will appear. Select patterns properties and modify dimensions. Yeah, Rohit has already done. Good. For PCB design, practice is really important. Yeah. So some of you already replied. It means that you are active. You are not in sleeping mode. So next, we'll place other components. So look at our PCB. What are other components here? Like other components are this box tip. What we'll do is we'll now put box tip. Just count number of legs. How many pins are there in this strip? 1, 2, 3, 4, 5, 6, 7, 8 pin. So on this side, 1, 2, 3, 4, 5, 6, 7, 8. See, connector types are available in software. And for box tip type of connector, important is pitch. What is pitch? Let's understand what is meant by pitch. Distance between two legs of the component is called pitch. Like here, let me give an example. Distance between two IC legs here is called pitch. So this distance is called pitch. Similarly, distance between two nearby pins in this connector is called pitch. So in the data sheet of these connectors, in the data sheet of microcontroller, pitch is given. And you have to select, for microcontroller I say automatically it is done. But for this connector, I search different type of connectors, but this type of connector directly it is not available. So I use foot pattern of other component having same pitch. So here pitch is 2.54 mm. It is standard value. So components are available with 2.54 mm pitch, 5 mm pitch, 1.24 mm pitch, and so on. So we will select now this 8-pin connector, these connectors, and at the same time we'll also, because this is also 8-pin, so we'll select these connectors, and it is very easy. Again, you click on place components like this, place components. You can keep library patterns. Library name is patterns. Click on the general. Click on the general and directly type letter H. Directly type letter H. So in components, you will see components names begin with H letter. So what we need to do is HDR. So this HDR, it is 1 by 2. That is 1 row, 2 pads. HDR 1 by 3. 1 row, 3 pads. HDR 1 by 4. 1 row, 4 pads. We need 8 pin. So HDR 1 by 8. Select HDR 1 by 8. I repeat the step. Click on the place components. Library must be patterns. Click on the general. Click on the general. Go to the edit box of components here and type H. When you type H on the keyboard, component beginning with letter H will be displayed. And what we need is HDR. So HDR 1 by 8. We need 8 pads in the connector. So this footprint will have 2.54 mm pitch. And then click on the place. So click in the editor window. This connector is placed. We need 2 connectors, but we'll select only one. After that, press escape button. Look at the cursor. Once you hit the escape button, cursor will be changed. Now what we'll do, we'll modify its dimensions. After modifying dimensions, we'll copy and paste. We need 2 connectors, similar connectors. So double click on it. You will see here details. What is the name of connector? What is the name of pattern? These are the details. So later on we'll see how to modify this. So time being, what we'll do same thing. We'll modify pad dimensions. So right click on any one pad. Pad properties. In this dialog, change the width and height. What is the width? 1.8 and height is 2.8. Hole diameter is 0.9. Shape of the pad is oval. And type is through hole. We are using through hole. Other is surface. We are not using SMD connector, so type must be through hole. See, there are 2 types of pads. SMD pad and through hole pad. Our pad is through hole. After that, apply to. On the bottom side of this dialog, you will see apply to all similar. Similar for selected pattern. So anyone you can select here. Similar, all similar. And click OK. See here, pad dimensions are modified. Only one pad is left because it is rectangular. So separately repeat this operation. Pad properties, patterns pad properties, 1.8, height is 2.8. And what is shape? Oval. Shape must be oval. Click OK. So we have modified pad dimensions. Now we want this connector in vertical position. This is right now it is horizontal by default. So click on it and press Ctrl R. Ctrl R is used for rotating the footprint. So if you, after selecting, if you again and again place Ctrl R, it will keep on changing its orientation. We want vertical. And just by selecting, you can drag it. You can drag and drop where you want to place it. Just drag and drop. We need 2 connectors. So what I will do is, I will copy this. Select this connector, copy this, Ctrl C, and paste it, Ctrl V. Another connector we want to place it here. So what I will do is, I will stop here. I will end today's session here. We'll meet once again tomorrow at 10 o'clock. And tomorrow we'll complete entire PCB design of PIC development board. And day after tomorrow, we'll complete PCB design of touchpad panel. And one day we'll spare for programming the PIC development board. So I will talk about small program, LCD interfacing program in last session. So thank you for joining today's session. We'll meet once again tomorrow.